begin? Alright, so good morning everyone. How's everyone doing today? Good. Before we begin, I just want to ask a couple of questions, but I could please have some help from the audience. How many people have an Android phone? A couple of people? 3? Yeah.
Any of you guys like music?
Yeah. I like music.
2 people like music?
That's pretty good. Important one. How many people have had trouble learning how to play the piano? I know I have. They're just black and white keys, so there's no labels.
Well, these were kind of the reasons why we decided to make Note Detection, the Android application. I'm Kenneth, this is my partner Carlos, and our advisor Dr. Azadi.
The outline for today, we're going to introduce what is Note Detection, our app. We're going to tell you how it works. We're going to show you the hardware and software we used. We're going to explain how we did it, and show you our timeline and constraints and conclusion. So what is Note Detection? Here's a screenshot of the app when you first turn it on. It's an Android app. It records you playing the piano. You can play it back to hear what you just played, and you can save it as a .wav file to your Dropbox account, and it'll actually display the note you played right there.
So this is a screenshot of our phone that we used. This is an arrow pointing to the icon of what it looks like on the phone. So when you click this icon, it'll bring you to the screen on the left. This is the home screen. And in order to successfully run this application, we have to follow the directions given. The first direction is to link with Dropbox. That's this right here. So if we click that, the screen on the right will pop up, and we want to click Allow. This will enable Dropbox to talk to our application, and the other way around.
So you can start your recording. You press number 4. You play on the piano, 1 note or a couple of notes, however much you want. You hit stop recording, number 5. You'll see this message pop up. It said added file. It actually takes the date format and saves the .wav file to the directory on the phone. And you can play it back to hear what you just played, or you can hit save note, which will actually save to your Dropbox account. You'll see the following screens right here. It says analyzing data with a little spinning loading wheel. Eventually you'll see audio successfully uploaded to Dropbox, and then audio being analyzed, which is actually occurring in MATLAB. We'll explain later.
So when the file is in MATLAB, MATLAB generates a picture of what we played. So when we want to get the note, we press Get Note. Then we get a message saying that it's downloading the image. And when the image is downloaded, then the picture from MATLAB pops up into a gallery. This is viewable on the bottom right here. If we played multiple notes, this is how it would look like. It originally starts out with 1 note, and if you slide your finger across the picture, you can see the transition on this, and it will come to the next note played. So in this sequence, the user played C4 and then E6.
So now you know how it works. We're going to explain our hardware and software we used during the project. We used my keyboard, Yamaha DGX 220 piano. It's pretty sophisticated and has 77 keys.
This is just a little graphic of the exact piano that Carlos has. It ranges from E1, which is 41 Hertz, all the way to G7, which is 3,136 Hertz. Those are frequencies because every key has its own individual frequency, and that's how we're able to determine what was played. The notes closer, like the lower notes, are very close together. So E1 is 41 Hertz, and the next note may be 44 Hertz, whereas the farther notes are more spread out. G7 is 3,136 Hertz, and the next note from that may be hundreds of Hertz away. This is our other piece of hardware. This is the phone, which Carlos has. This is the Google Nexus S smartphone.
So we're going to the software we used during the project, Android SDK. It was heavily Android programming. We had the latest version, API 16, and we needed to use an ADT plugin, which is the Android development tools, which we could use to work in conjunction with Eclipse, which we program all in Java. Other programs we use is the virtual hard drive Dropbox. We needed the API, the application programming interface, so we can integrate it into our Java code. And we use MATLAB for file analysis.
Now that we looked at the hardware and software, we're going to get into how it works. This is a flow chart for the whole system. It's very small, so I'm going to do my best to project this. First, we record the sound, and the audio files is converted from a 3GP file to a WAV file. 3GP is the default audio for Android, and the reason we're converting it to a WAV file is so someone can view this on their computer. If they want to save it to Dropbox and look at it at a later time, they wouldn't be able to view the 3GP file, which is why we convert it. Here, we're saving it into the Dropbox directory, where MATLAB will be looking for a new file in this directory. If there's a new file, then it will perform a fast Fourier transform and obtain the frequency. It will match this frequency with a note, and when this note is produced, MATLAB will send it back to the directory, back to the Dropbox directory, and our phone will be looking for a picture. So it's polling, it's looking for a picture, and when this picture is finally found, the phone gets it and displays it on our gallery.
So now we're going to go more in depth. We're going to show you a flow chart for each individual button. This one's concerned with link with Dropbox, and also unlink from Dropbox, which is the same button. So when you press link with Dropbox, we ask, are you logged in? Obviously no. So we authorize a session, we perform a login, and we change the button text to unlink from Dropbox. When you click it again, are you logged in? You are. You perform a logout, and you change the text back to link with Dropbox. When you press the start recording button, Android starts in media recorder, and it just starts recording, and it creates a .3GP file of that file, and it'll wait for you to press stop recording.
So the next button is when you hit stop recording. This tells the audio recorder to stop recording. It will then convert from a 3GP to a WAV file, and at this time it will get the date and time format of when you hit stop. This way we can create a unique name for this file. This is helpful for if someone wants to go back and look at what they played, they can know when they played it, and it'll be easy to search for it. Once we do this, we save it to the phone as well, and a message comes up telling you exactly where we saved it to the phone. This way it's easy for the user to find it if they want to do that. And lastly, we get the location of the last saved file for a playback option. So when we hit play, we initialize the media player. We get that location that was talked about from the last step, and we play the file. This is played through the speakers on the phone.
So now we're dealing with the save note and get note button, which is also the same button. We have a variable called check flag. So when you press save note, we ask what is the number of check flag? Is it 0? So it's initially 0. So we'll go to the right side of the flow chart where you save the audio into Dropbox. You change the variable flag to equal to 1, and you change the text to get note. So when you click get note, check flag equals 1. So you go to the left side of the flow chart. You get the picture from the Dropbox, and then you add the picture to the gallery on the phone, and you set the flag back to 0, and you change the text back to save note. And now I'll explain a little about how MATLAB works into this. It's constantly looking at the Dropbox directory, and it's searching for a new .wav file. Once it finds one, it applies a fast Fourier transform on it, which grabs the frequency of that clip. And we compare that frequency to our notes database. We have a picture of all the notes, all 88 notes, and we save those pictures into Dropbox.
Now that we just went over how it works, we're going to look at the timeline that we followed, or actually completed, and we'll go into our constraints.
So this is the timeline, the Gantt timeline we made in Microsoft Project. We have start at the bottom, starting at the last week of August, all the way to a couple days ago at the top. It just shows all the tasks we used during the making of note detection. You see the first thing we did is trying to get record sound in the phone. Big one, the black chunk, is the design of the app. We constantly made improvements. We did that the whole time. Other big issues was integrating Dropbox, the transform. This was a big issue too, converting 3GP to .wav. We needed that because MATLAB only accepts .wav files. One thing I wanted to say about the timeline is we didn't do one task and then next task. You can see we worked on several tasks at the same time. And this wouldn't have been possible without good communication between Ken and I. The ability to work together well was crucial for the success.
If we look at our constraints, we have 4 constraints. We have social, environmental, manufacturing, and economic. I feel like music in itself is very social. So a music lover would very much enjoy our app. It's environmentally friendly because we're not using any extra hardware. If someone has the phone, then they can get our app. We go with the manufacturing constraint because we're not building anything. It's just downloaded. So anyone who has a phone can just have it downloaded to their phone. And it's very economic because not only did we not spend money making this, but if someone would like to have it, then it would be free. They don't have to pay for it.
So for a conclusion, Note Detection is a good app. You could use it to help you learn how to play the piano. You could also use it if you play something nice you want to remember. You could save it to your Dropbox account for later. It can be improved. We can talk about that later. This design couldn't have been possible without the courses we took here at SUNY New Paltz. Courses such as Embedded Linux, which was Android development, Computer Science 1 and 2, Java programming, Software Engineering, the design, being able to work in a team, and engineering computing too, as in MATLAB. It was an excellent experience for us. We had a lot of challenges, we overcame them. App development is a hot job in the market right now. We definitely have more experience now because of this.
If we look at an extension, if we were to further proceed with this idea, right now we're very reliant on Dropbox and MATLAB in order to accomplish this. With an extension, we would like to move away from Dropbox and MATLAB and make this solely an Android application. If we can do this, then we could put it on the app market. We could do this anyway, but in order for a person to use this correctly, they would need MATLAB.
So we'd like to conclude with a demonstration. There's a video clip of Note Detection in action.
Hello, this is Kenneth and Carlos here. We're going to give you a quick demonstration on the Note Detection app. So this is what the icon for the Note Detection app looks like, this orange one right here. And when we click on that, it will bring us to this. This is the app home screen. And if we follow the directions, the first direction says to link with Dropbox. So if we click link with Dropbox, it'll bring us to this screen right here. We want to hit allow so that the app can access Dropbox and save everything and get all the notes from there. The next step is to start recording something. So Carlos here is going to record a few notes. And when we're done recording, we hit stop recording. We can also play this back to see if we like it. And since we do like it, we will save note. These notes get sent to Dropbox and picked up by MATLAB, where MATLAB analyzes it and sends it back to Dropbox, which will be ready for pickup by the phone. Now that we're back here, we click Get Note, where we'll start downloading the images. And just to check in with Carlos. Carlos, what notes did you play? C4, C5, C6, and then C5. So just to make sure that our app works, we can view this gallery, and we got C3, C4, C5, C6, and C5. So the functionality of our app was 100%. And that concludes this demonstration.
And the program we used, do you remember the name of it?
Camtasia to record the. That was very nice.
And what you saw at the phone was actually us on a phone, but we hooked it up to the computer so you could see the screen of what was actually going on. We'd like to give a special thanks to Dr. Nitya. She's very good with Android, and she gave us some really good ideas. The Dropbox was an idea from her. And of course, Dr. Azadi, you've been a lot of help, and this was really good. You want to say anything about Dr. Azadi?
You want that recording?
Yeah, I guess. Dr. Azadi has been very resourceful. He picked us up when we were down, and we couldn't have done it without you.
Why don't you let your app replay what you said in his behalf?
We can do that.
Are you planning to patent this, market it at all?
We have to keep working on it to separate it from the.
Not until the
How much
extension.
you're able to actually record? How much of a song, for instance, if you were to play a song, could it record?
We could record a lot. However, the longer you record, it takes that much more time for the app. So it's much quicker if you just record maybe 5 notes compared to 25 or 50.
So what would you downfall, lack of memory resources, or?
Yeah. Well, yes. And right now we're using MATLAB, and that almost kills his computer just running that for the 5 notes.
You want to show them your app on the Android?
Oh yeah, we could. Want to pass it around?
If you just turn it around and show them.
Record something.
So here's the app. You can link. I can just record right here. Say hello, hello. So I'm gonna just play it back. Say hello, hello. And then I can save it. If I open my Dropbox account, I can play the audio file from there.
Are you both computer engineering major?
Yes, sir.
Yeah.
And you would say that Java is essential
For this, yes, because that's the language. Well, you want to talk about this?
Yeah, originally we wanted to do C because we're engineering majors, but Android, we could use an Android NDK, which is a native development kit, but they don't recommend to program an entire application in C. It's used for like fixing patches, make it a little bit faster, but it's really just Android, Java, to making the app.
We would have much rather program this in C, but we had to do it in Java, which wasn't too terrible in the end.